Hello and welcome to the problem solving video of Python Bytes. In this video we will see how to convert an integer to a Roman number. Let us see how to convert integers to Roman numbers. To convert integer to Roman numbers, we first need to understand what are Roman number symbols. So for 1 the symbol is I, for 5 the symbol is V, for 10 the symbol is X, for 50 the symbol is L, for 100 the symbol is C, for 500 the symbol is D, and for 1000 the symbol is M. So these are symbols from 1 to 1000, but there are some symbols in between also that we will see. For 4 the symbol is IV, for 9 the symbol is IX. So here we see whenever a smaller symbol comes before a larger symbol, that denotes that it is a subtraction. So 5 minus 1 is equal to 4, 10 minus 1 is equal to 9. So similarly for 40 the notation or the symbol is XL, for 90 it is XC, for 400 it is CD, and for 900 it is CM. So there are these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 symbols which are we need to solve the problem of integer to Roman numbers. So now let us understand the logic behind how to do it. So if a number is 25, we can manually divide it into two parts, 20 plus 5, and we know that 20 is XX and 5 is V, so 25 is XV. Similarly for 75 we can divide it into 70 plus 5, but we can still divide 70 further into 20, 50 and 20, and now we know for 50 the symbol is L, for 20 the symbol is XX, and for 5 the symbol is V. But this is all done manually. How are we going to do it programmatically, or how are we going to write a program? So we have learned two operations, that is remainder and modulus, and we are going to use that to solve this problem. So let us take the number 75 and let us find the next largest number in our symbol list, and that number is 90. So we will start our operation of modulus. So remainder of 90 is 75, and let us see the modulus part with 90 is 0. So if the modulus is 0, there is no symbol to be added to our list. So I'll just write we'll write our solution in this part. So we take the remainder and we continue our operation. So in the next operation we'll take the next smaller number than 90 in our list, so that is 50. So we take remainder with 50, that comes to 25, and the modulus part if we take, it comes to 1. So now we got 1, so this is our first symbol. So remember, in Roman we go from the larger symbol to the smaller symbol. So our solution part, the first part is L. Now we have a remainder of 25, so we take our operations 25, and now in the list of the symbols, so we have already used 50. Now we go to the next smaller number, that is 40. So we take 40, remainder is 25, and if we take the modulus part, the remainder is 0, but the modulus is 0. So there is nothing to be added over here to our symbol list. So we take the remainder 25, and now we go to the next part, and that is 10. So we take 10, and if we do remainder 10, we get 5, and modulus 10, we get 2. So here now we get another set of symbols to be added to our solution. So let us make it LXX, and so we are going to continue our operation because our remainder is not 0, so we'll take 5, and the next number after 10 is 9. So we take remainder with 9, so that is 5, and modulus with 9 is 0. So if it is modulus is 0, we continue our operation. So we take the remainder 5, and now the next number in our list is the next smaller number than 9 is 5. So we take remainder with 5, that is 0, and modulus with 5 is 1. So now we got our next symbol over here, that is v. So we add it over here, and as soon as we reach 0 in the remainder, that is where we stop our operation, and we get our solution with that. So 75 is LXXV. So now this is how we are going to create our code, and now let us jump to the programming part and see how we write these all operations in a systematic way in our code. Now we have seen the explanation. Now let's implement that in the program. So we have declared two lists, R and R, so N and Rn. So N has all the critical numbers that we want for converting the integer to Roman, and NR has all the corresponding symbols for those numbers. So for 1 there is I, for 4 there is IV, and so on till 1000 we have M. So now let us start coding. So this Roman number string is what we are going to return, and that is what we want. So in the explanation we saw that we started with the largest number. So over here the largest number is 1000, and we will need the index of this number. So the index of that number is I is equal to, so index of this number is length of that list minus 1. So because minus 1, because in Python the indexing starts with 0, and the last index is the length of the list minus 1. So we start with length n minus 1. That is the index we start our operations with. In the explanation we saw that there was a loop, there are repetitive commands, so we have to use while loop, and the exit condition for while loop was when remainder. So let us first declare remainder over here. So remainder is at the start of the code, it is the number that we are inputting. So while the remainder is not equal to 0, till the point remainder is not equal to 0, this loop will keep going on. So what are the operations? So we first find the quotient, and that is remainder modulus, so the number and the index. So we start with the largest number, and then we go to the next operation, that is remainder. So we now find the remainder from that part, the remainder Ni. So now we have found the quotient and the remainder, and now we are going to find if there is any Roman number that we can add to the string of Roman number. So we do string concatenation. So Roman number plus. So what is the symbol that we have to add to the Roman number? So this is the quotient part into, so number of times the symbol. So how are we going to take the symbol? That is Rn. As we know that all these, both the lists are of same length, the index are shared by the number and the symbol. So Roman number index I, and now we reduce the index by 1, and that is reduced I minus equal to 1. This is an operation where you can see if you want to do I equal to I minus 1, it can be, this operation can be denoted in this format. It is a shorter version of it, and this operation will keep going on. So while loop will keep going on till the remainder is not equal to 0. So, and then we output the Roman number. So this is our simple straightforward code. Now let us see it in action. So integer, and let's convert 10 into the Roman number. Because this function is returning a Roman number over here, we will need to either store it or print it. We'll directly print it, and now let's run it, and we say that is not subscriptable because we used a wrong bracket over here. Let's just fix it. We have to use a parenthesis and not a square bracket. So let's run it again, and we get output as X. So this number 10 is now converted into X. Let us take the example number that was 75, and let us run our code. We get output as LXXV. So L was 50, XX is 20, and V is 5. So that brings us to 75. With this script, we can go maximum. So let me reduce a little bit so that everyone can see. So with this script, we can go maximum up to 3999, because beyond that number, we'll need to add a new symbol over here. So let's see what is the maximum output that we get, 3999. And now when we run it, we get MMM. This 3M is 3000, this CM is 900, this XC is 90, and this IX is 9. So this is 3999. Now if you want to print any number, you can just enter it, but the minimum number is 1 and the maximum is 3999. So let us go to the year 2022 where we are right now, and let us print it. We get 2 M's, 2X and 2 I's. That's 2 M's is 2000, 2X is 20 and 2 I is 2. So 2022. Thank you for watching this video. In this video we saw how we use basic operations and data type to solve problems in Python. Click on the top right corner to go to the Python Bytes series. In this series I have shown how basic operations are used and how data types are used in Python. Please like and subscribe to this video. Please post in the comment section with your comments and suggestions. If you have any question that you want me to solve, please post it in the comment section. I would love to solve it for you. Goodbye till next time. Keep coding.